Hey guys, welcome. This is the first video. We'll talk about the big picture and then go through the course and learn all the little details about this big picture. All right. So our course, of course, is chemistry. Chemistry is our course. All right. I'm gonna make this a little bigger. And so, what is chemistry? When we think about chemistry, all right, there's two things. All right, I think of reactions. I think of chemical reactions. All right, and so what is a chemical reaction? Well, chemical reaction, right? One thing a chemical reaction is a redistribution of electrons. And the other thing I think of in a reaction is a rearrangement of atoms. All right, we got the law of conservation of mass. It didn't change color on me. Sorry, guys. There we go. So we got the reactions. So chemistry is reactions, right? And we have the law of conservation of mass. They rearrange the particles from reactants to products, right? And so a reaction, we got reactants to products. And the law of conservation of mass applies again. We're changing the atoms around, changing the electrons around. All right? Now, what is the control then? The control of the reaction. What are the two types of controls? All right? Well, there is the energy or thermodynamic control. Which we've touched on in Chem 1. So if you've taken Chem 1, you've touched on that, right? Okay. There's also the kinetic control. All right. So when we talk about control of the reaction, there's two. There is the thermodynamic control and the kinetic control. All right. When we talk about kinetics gives us two things. It gives us the rate of the reaction. How fast does this reaction proceed? How fast is it going to go? All right, and that's important. Right? How fast is this going to react? Right? Medicine's a great example of this. Right? How long is it going to take so you can feel it, and then how long is it going to last in your body? These are good things to know. Right? And then kinetics also tells us the mechanism, or how the actual reaction works. What's touching what? What's bumping into what? What are the the steps to get from your reactants to the products? Same thing, analogous to dinner. You come home with, your grocery bags with stuff in the grocery bags, and you maybe use some stuff already in the pantry and the spice cupboard, and you do some steps. And you got to do those steps in certain order to make a finished product that you want to eat. All right, it's the same thing with the chemical reaction, except we're not going to eat them. We're going to use them for whatever we're going to use them for. So that's the kinetic control, and we're going to dive into that, a whole chapter of that this semester. The thermodynamic control, there's two things. All right, the thermodynamic control tells us if the reaction is spontaneous. Right? And it tells us how far, all right, the reaction proceeds. All right, so does it go to completion? Does only half of it react? Does all of it react? How much product we're going to make? Okay, is the reaction spontaneous? Is it going to happen? Right? Okay, Right? Like if you live in the southeast where I live, and you have anything metal outside, it's going to rust. You don't have to worry about it. It's just going to happen, right? And so that's a spontaneous reaction. That's unwanted. Okay? Now, with this spontaneous, right? Okay? This thermodynamics, how far the reaction proceeds, there's something else here that we've learned. So we learned already previously, this is a previous Chem 1, all right? We learned about delta H, enthalpy. So when it comes to this, reactions can be enthalpy driven, which means delta H, if you remember that, delta H is negative, right? Which means heat's out, right? Because delta H, enthalpy, was heat transfer at constant pressure, right? And so a lot of times when heat's released in a reaction, the reaction tends to be spontaneous, right? It can also be entropy driven, which is a new one, which that is delta S, positive, right? Which is a randomness or disorder. It's actually a thermodynamic function we'll talk about this semester, right? So it could be enthalpy driven or both. All right? And so when we talk about this, right, we want to talk about enthalpy, right? I want to talk about what makes delta H negative. All right, you ever think about why is delta H negative? All right? What makes a reaction exothermic? All right, that's the question. Okay? And most of the time, it's a more stable arrangement of electrons. So if we took this redistribution of electrons up here, all right, if we come down with this, all right, oh, I didn't want to do that. So we talk about redistributing the electrons. There's two ways. All right. First one is acid base, right? Which there is no change in oxidation number. And a lot of times we call this H plus or proton transfer. All right. And then the second way we redistribute electrons are redox. Right? And that has a change in oxidation number, because those are electron transfer reactions. All right? So that is a snippet of the big picture of what we're going to talk about this semester. Now, towards the end, we're going to do another one, and we're going to have a lot more details put in. But that's the big picture. That's what we're looking for, why we're looking for it, right? How all this stuff works, okay? So hopefully that makes sense, and we'll see you in the next one, guys. Take care.